So it's capable of injecting that venom into the prey. Yeah.
With the Opistoglyphus, if not to immobilize the prey before eating, what would be the main function of the venom then? Just to...
It does reduce the amount of struggling in the long run, right? So that once the animal's first contacted, there's no venom and it's struggling mightily. But as soon as it gets a little bit back into the mouth, then you can put the prey into it, which will make the rest of the job a lot easier. Proteroglyphus, they're in the front. These two are rigid and erect. They tend to be, let's say here's your fang coming down. So they're larger than the other teeth, and they'll fit inside a pocket in the lower jaw. So there's a little space for them to go into there. Proteroglyphus are the types of fangs, rigid, erect, and in the front, that you find in the elapids and the hydrophiids. Selenoglyphus, only found well in front of the mouth, very long, and they're hinged. So you're somewhat limited. If you have Proteroglyphus and you're putting your erect fangs into a pocket in your lower jaw, you're somewhat limited into how long you can make that fang. Because otherwise it's going to be sticking way out and disrupting your entire body. But if you can make your fang very long, and then you can fold it backwards. Well, that's a very bad drawing. Anyway, Selenoglyphus is a fang that can fold backwards into the mouth. It's very large. That rattlesnake that I passed around had one. This is just another example of a rattlesnake with a Selenoglyphus fang. So family Viperidae has these foldable fangs on the front. And so the advantage is that you can have this being much larger than a Proteroglyphus fang because you just fold it back into your mouth and out of the way until you need it. And when you need it, you erect it and use it to lash out at prey or predator. And that's also what they're showing in this diagram here. So yes, it illustrates craniokinesis, but it's also illustrating the idea that you have your fang in the folded up resting position, and then it can be rotated outwards, ready to strike an individual. And they sort of have the same thing in this particular diagram. So there it's folded up, and here that it is being rotated outwards for use. All right, one last thing then, dealing with snakes and venom. It's the idea of mimicry. Well, warning coloration and mimicry. What do we call warning coloration? We saw it with the dendrobatids and the amphibians.
Bright.
Well, it is bright, but there was a word that we used. No, that's a type of mimicry. Yep. All right, so aposematic coloration is warning coloration, and the dendrobatids were brightly colored. Well, we do find that in a lot of the snakes as well. Okay? Snakes will advertise. You know, a rattlesnake advertises by not through coloration, but by making a noise that essentially says, "Back off, buddy, you'll be sorry." Right? But other snakes, especially in the Elapidae and somewhat the Hydrophiidae, are brightly colored. So they're using the same concept that the amphibians use to prevent predation on them. They make themselves brightly colored, they advertise the fact that they're there, and that coloration provides them some protection. You know, we saw that with the coral snakes with the red and the yellow and the black. It's a very brightly colored snake. So that's aposematic coloration. But a large number of colubrids, which by and large are not poisonous, there's only a couple of poisonous colubrids. Many species of colubrids have evolved similar coloration to the elapids. In other words, bright red, yellow, and black rings. And that is a particular kind of mimicry called Batesian mimicry. Batesian mimicry occurs when you have a poisonous model, venomous model, and a non-poisonous or non-venomous animal that mimics the poisonous model. Right? So the venomous or poisonous model here is the coral snake with the brightly colored reds and yellows and blacks. Colubrids have mimicked that coloration. Even though they are not poisonous, they appear to be so to many species of predators. And therefore, the colubrids benefit by having reduced predation, presumably, because they have this coloration that suggests that they're poisonous even though they're not. Right? And most people usually want to know about Mullerian mimicry. Mullerian mimicry is just when both are poisonous. So they converge on a particular, let's say, color pattern. And this would be true of many poisonous snakes. It reinforces the power of the signal. If we're all going to do warning, it would behoove us to all look alike, because then the stupid predator doesn't have to adapt to too many patterns. So Batesian mimicry is when you have the non-poisonous mimic. Mullerian is when a poisonous species or venomous species mimics another poisonous or venomous species. Okay. All right, I'll quit. And that'll be the end of lecture material for the exam. Now, what have I got for you? I have goodies. Lab is going to be starting on birds. It's a little inconvenient because there's just no space in this room, but I do have representatives of most orders and families that you have to know. So we're doing the same thing that we did before. You're going to do orders and families worldwide, and then next time I'll have Michigan species out. You'll have to know, I don't know, about 25 or 30 Michigan species. Okay? And I will send out bird calls, and you have to know those. In addition, has anybody got that handout from Lab? You know, that had the snake glossary and all that?
This one?
Nope,
This
nope,
one?
nope.
No. This?
No. It has fish drawings on the front of it, that one. Yeah. The last page in this indicates some silhouettes. And on the lab exam for the Michigan species part, I will put some of these silhouettes on there. So you're not getting the color information. This is just like, you know, you've got a bird on a telephone wire, and it's the sun is in back of it, and you can't see what color it is, but you can tell what kind of bird it is by the basic outline. Now, I don't need you to know all of them, so I put a line, a horizontal line, next to the numbers indicating which of them you should be able to identify. Okay. So, we will do orders and families worldwide. We will do Michigan species, Michigan bird calls, and those, what would you call them? Silhouettes, thank you. Yeah.
The date for the bird practical is a week from Wednesday. Are we sticking with that?
I think we can do it so that if we do orders and families worldwide today, and then you have 2 days on Michigan species, that should be okay.
One day. Unless we plan on staying after the exam.
Well, I mean, are you saying there's only 2 labs, or there are 3 labs? I thought I looked this morning and there were 3.
2. Well, we have today. Wednesday is the exam, so that's not a day. Unless I want to stay after the exam.
Oh, we can't do that to you.
And then Monday, and then.
I'll look at that. I want you to have a minimum of 3 days in lab working with the birds. Okay, I thought it was there. All right. Okay. What else? Oh, this handout that I gave you, it's rather lengthy, and it's from an old ornithology textbook. But if you're looking for clues as to helping you to identify the different orders and families, you can get a lot of them out of here. And the other advantage of this is that you have a lot of drawings of what the birds look like that belong to various orders and families. Right, so I think that this is really a pretty useful study guide for you. All right, so I have a bunch of the taxidermic mounts are over there. We have a few things up in front on this side. Oh! You want to see Sex and the Snakes? So okay. I forgot, that's why I had that all.
For 26. It's only 16. That's
So,
Yeah, but I gotta work on my mammalogy paper and my naturalistic research paper and the proposal for mammalogy, not for.
I think I'm gonna try to have him in my topics. Oh, I don't know if he will.
And I gotta finish picking it. Yeah, you can do.
Did you read through his like that email he sent us over spring break and you got spraying and you got topics for your
Yeah.
This was one of the topics that he had actually put on there. I was like, well, that sounds really interesting.